Imagine a Singapore semiconductor fab, clean room running at full capacity, every wafer worth thousands of dollars. Suddenly, an invisible 80-millisecond event, barely a blink, wipes out an entire production batch. No blackout, no alarm, just a momentary dip in voltage. This is the silent profitability killer that most manufacturers don't even know how to measure. I'm Colin Koh, Principal Consultant at LKH Precicon, and in this series, we're going to show you exactly how to fight back. Let's start with the definition. Per European standard EN 5160 and mirrored by Singapore's SP Group guidelines, a voltage dip is any sudden reduction of more than 10% in supply voltage, lasting between 10 milliseconds and 1 minute. Now, here's what makes this tricky. Voltage dips are not power outages. The supply never actually cuts off. But for sensitive equipment, VSDs, PLCs, control relays, semiconductor tools, that brief sag is enough to trigger a trip. So where do these dips come from? Three main sources. First, equipment faults elsewhere on the shared grid. A fault in your neighbor's 22 kV feeder becomes your problem in milliseconds. Second, underground cable damage from earthworks nearby. Singapore has strict EMA and SPPA protocols around this, but it still happens. Third, large motor starts or transformer energization within your own facility. You can actually cause your own dips, and critically, Singapore's EMA regulations are very clear. If your installation causes 3 voltage dips within a 24-month period, you must engage an independent licensed engineer for a mandatory audit. Your electrical supervisor's license can be at risk. Here's data from a real Singapore industrial site. Voltage dip records from 2020 to 2023. Look at this event. 26 May 2021. Remaining voltage dropped to just 12% for 0.3 seconds. Now, plot that against the SEMI F47 standard, the baseline for semiconductor tools, and you'll see it falls outside the protection zone. Even the more stringent IEC 61000-434 Class 3 standard cannot protect against that event. Only one standard covers it: the Samsung Power Vaccine, which demands uninterrupted operation through a 100% dip for a full second. This is why you cannot rely on equipment specifications alone. You need active mitigation. So Chapter 1 key takeaways. Voltage dips are unavoidable. They are a physical reality of any interconnected power grid. They don't interrupt supply, but they can devastate precision manufacturing processes. Real incident data shows that standard specifications like SEMI F47 are not sufficient against severe dips. In Chapter 2, we'll show you the first line of defense, knowing exactly what's happening on your power supply with precision monitoring. If you found this valuable, subscribe and follow me on LinkedIn. Link below. See you in the next chapter.